Hey, Mrs. Wetherell here. I'm going to show you some word problems again using Desmos. So our first example says a model rocket is launched from the roof of a building. Its flight path is modeled by h equals negative 5t squared plus 30r plus, 30t plus 10, where height, h is the height of the rocket above the ground in meters, and t is the time after the launch in seconds. What is the rocket's maximum height? So we've got height in meters, you're thinking the y-axis. Seconds would be your x value. So putting this equation into Desmos, I have a graph. Now, what you can do is you can find the maximum height. That is where you're going to be your vertex. Where does it start changing direction? You can zoom in and out. You know that by now in Desmos. I don't want to zoom out too far, so I want to be able to see that. So if I click that and make that a black dot, you can see that the maximum or the vertex of this, the y value, is 55. So the maximum height you're going to get when you get in this function is 55 meters. So 55 meters. So looking on to another problem, this one I'm going to present in screen mode, in full screen mode, so you can see the problem, and then I'll go back. So a water balloon is capsulated into the air so that its height h in meters after t seconds is h equals negative 4.9 t squared plus 27t plus 2.4. I've got a series of questions here. So how high is the balloon after 1 second? For how long is the balloon more than 30 meters high? What is the maximum height of the balloon? And when will the balloon burst as it hits the ground? So let's type this into our Desmos calculator. So typing that equation in, you can see many things. So the first question is, how high is the balloon after 1 second? Well, I can go to Desmos and look at 1 second and try to figure out the graph. But if you remember, we can go to this gear in our equation and select the table. We could type in any value of x we want, but we can see x is 1 is already there. So how high is it? Well, it's 24.5 meters. So if you can look at 1, you see that 24.5 meters is your answer. So I'm going to go back into my question, my equation, my function, and let's see what else we're looking for. So for how long is the balloon more than 30 meters high? Okay, looking at my graph, I'm going to find 30 meters, my height of 30 meters. Okay, here's 30 meters. So I have a point here when it's just about 30 meters, and I'm going to round to the nearest tenth. Now this one I have to hold. I can't just click on it. So looking here, I can see that approximately it's 1.4 seconds. So I'm taking my x value because I'm looking for seconds in time. So 1.4, and it's how long is it above 30 meters? So how high is that balloon in the air above 30? Going back here about when it's 30, and you can just move your mouse to find when it's closest to 30 and get an approximate answer here. So it is approximately 4.2, rounded to the nearest tenth, excuse me. So 4.2. So if you subtract 4.2, you have your 4.2 minus your 1.4, you can see that is higher than 30 meters, approximately at 2.8 seconds. The next question is, what is the maximum height of the balloon? So again, I'm going to use my graph for this one. The maximum height is where your vertex is, and this one you can click and get a black dot to show you exactly. You don't have to hold your left mouse key. So it is approximately, let's just go to the nearest tenth again. So what is the maximum height that this balloon will go into the air? And I get 39.6 meters. So 39.6 meters is the height. So I found all this information from just typing it into Desmos and analyzing the information that I have. The final question, D, when will the balloon burst as it hits the ground? Well, if you remember, okay, first let me click this home button so I can see my x-axis. The ground, you think about an x-axis is horizontal, if that helps you remember. And we're talking about seconds. So this value over here, negative, doesn't make sense. So I find the value here, I can click on it, and it is approximately, so that balloon is only in the air for 5.6 seconds before it hits the ground and bursts. So 5.6 seconds. So that is using Desmos with word problems to analyze graphs and